Next. So now we have seen two conditions that we must satisfy. So the second condition, we still don't know how to satisfy this, and we will see that hopefully during the next week when we speak about things like word to vec. But this is at least we get an idea of how they should be. Now, the final condition that we are going to speak about is so we've seen two conditions. Now let's say, so I am using the same multi-layer perceptron. Remember, for example, for faster RCNN, right? For faster RCNN, what did we have? We had a ROI engine here, or sorry, region of interest, what are they called? Proposal network. And that proposal network, what did it give us? It gave us multiple proposals here in the latent space. This is the, what is it called? The convolutional feature map. Yeah, this is the convolutional feature map. These are our regions of interest. And before we send them through the multi-layer perceptron, we were doing something first. We were doing something called ROI pooling. What ROI pooling does is just it converts all of these different rectangles of different shapes into the same size, and then it sends it through the multi-layer perceptron. Same thing here for natural language processing. We have words or sentences of different lengths. So I am student, and we have another one. I am not a student. So let's imagine this situation where we want to embed all of these into the same, or like put all of these sentences into the same multi-layer perceptron. So our embeddings should be able to represent this sentence in, let's say, 20 variables, features, and this sentence also in 20 features. So our hopefully our embeddings should satisfy the condition, the third condition, which is same size. Now we would have like two options to do this. Either directly, the embeddings that we will use will convert any sentence into the same length vector, or the second option would be to change our neural network. So we would need either an embedding that is fixed for all sentences, or a neural network that is able to fit or able to read all different sizes of these factors. So it's either one of these two options. And today we will see that second option done through the concept of recurrent neural networks. So let's share the screen and let's start our lecture.
I'm sorry.
Yes.
What about the project presentation?
Yes, the project presentation will happen after 12 minutes. So we will continue this RNN lecture for 12 minutes, and then I will start the project presentations, and I will call for your other students who have not presented yet.
Oh, okay. Thank you.
Thank you. And I see the majority of the students who have not presented yet are not here. So I would have to text them to come and present. But let's go and start the natural language presentation. So for this one, we're going with the slides from Professor Fahim on natural language processing. And these slides are quite nice because they cover exactly everything that I wanted to cover. So natural language processing, RNNs, their architecture, their training, backpropagation, use cases, and then he speaks about LSTM. very beautifully. So we will be able to cover at least the needed part of the theory in here. And then when we go to the practice, we will speak about these word embeddings in more detail, and we will see how to basically build an RNN and how to train it. So natural language processing, as we have been discussing, focuses on the interactions between the human language, just basic text, and computers. Natural language processing is a way for computers to analyze, understand, and derive meaning from human language in a smart and useful way. I'm sure all of you guys have already used like ChatGPT, and you see how smart sometimes it is and how not so smart it is. So for example, I was using it last time to like do some research for Pepsi, and it was generating to me some just very smart sounding words with even some citations and names of like authors and names of papers and names of like different conferences. But when I checked all of those citations, they're all fake. So he was just basically building the citations as if it's just like another string that just contains a random author's name, I don't know, John Wick, and contains some random paper name that doesn't exist. And he was presenting, or ChatGPT was presenting those like that information as if it's an accurate like information out there. So yes, natural language processing models are very smart, but they're not actually smart. They're just like probabilistic models that are just printing out words that sound natural, that sound human. So we must be careful, especially with the final exam coming next week, careful with using ChatGPT like to the fullest. Recurrent neural networks, as we have seen, are a way for us to handle this problem of the data comes in multiple sizes, or this sequential information. So just like, for example, temperature day by day, it's a sequential information that changes. We have the concept of like text, which is a sentence that could be like 5 words long, or a paragraph which could be, I don't know, 200 words long. So these types of data structures, they don't follow the same, the same size or the same rules as we have seen before. For example, when we're working with an Excel or you're working with a CSV, you have very simple and structured data. You don't need to worry about resizing the data. When you're working, for example, with images, even if the image is like super big or super small, you can easily just resize it, just like stretch it out or just make it smaller. But when it comes to text, you can't really just change its size easily. There are some techniques, for example, like padding or something like that, but they sadly don't provide such good performances. And hence, we need recurrent neural networks to solve this problem and to handle the tasks of sequential modeling in a much better way. So in our case, the idea behind RNNs is to make use of this sequential information. Usually text, for example, is kind of dependent. Each word in a text is dependent on the previous sentences that came before it. So if the next word in a sentence is going to be predicted, there is the need to know which words came before it, right? So, and the size of those words depend on where are you in the sentence. So for example, if you are in this beginning of the sentence, you have nothing before, and you can just start it with something like once upon a time. And if you are, for example, in the middle of your very long paragraph, then the next word depends exactly on the context that you have been building up towards it. RNNs are called recurrent because they perform the same task for every element of a sequence, with the output being dependent on the previous computations only. There are different versions of RNNs where the output is dependent on the future also. So we have like bidirectional estimations, but that's another type of RNNs, just like a simple tweak. But for now, our definition of an RNN is just a model that can handle sequences very well and understands or reads data from the start till the end sequentially and recursively. Another way to think of RNN is that it has a memory which captures information and what has been calculated so far. So if we can think about it as just a simple multi-layer perceptron, that contains one very important thing, which is a hidden state. So let's imagine, for example, we have x1, x2, x3, and x4. So what happens is x1 will be fed into our RNN, which is just, multiplications and additions, you can think of it as just a normal neural network. And this x1 that will be predicted like this, it will be first mapped into a hidden state. You can call it a hidden state, latent state, whatever you want. This hidden state will be used to predict its y. But for x2, we will do the same thing. We will do just multiplication and addition. We get h2. But before we predict its y, we combine it with the previous h1. So we do some multiplications and additions. Everything is just multiplications and additions. So we do some multiplications and additions based on the previous value, and that would give us the context. Same thing for this h2 goes to h3. So for example, h3, here we go, we calculated through just a couple of multiplications and additions. Before we do the multiplication, or before we do the prediction of the y state, we do some combination between the previous and the current, and then we do the final predictions. So as we said, RNNs are here to model sequences. What is a sequence? It could be some time series data, like for example, the sales. Right now I'm working with Pepsi, and all of our data is time series data. So our models must be able to contain, or must be able to handle very well the concept of time series, concepts such as seasonality, concepts such as trends, and how they affect basically the sales of PepsiCo. Other cases, for example, are what are they called? La bourse, like trading, for example, when you're trading Bitcoin or something like that, and the prices are going up and down. So these are another example of time series data. Languages, all languages are sequence data. There are some languages which are not sequences, but I think these are like extreme exceptions. For example, all the languages that we currently speak, such as English, Russian, or Arabic, or whatever language you're speaking, they're all sequences that are easily read. Speech, which I'm just speaking right now, and you're seeing it's a sequence of words, and many other techniques or many other sequences out there. Videos can also be considered as sequences of images, right? RNNs can successfully generate things like TED Talks, Eminem rap. So I'm sure some of you have seen that Eminem rap about cats that was generated using ChatGPT, and the song is actually very nice. And it can generate music and many other things, right? So to model sequences, we need to first, as we said, deal with variable length sequences to maintain sequence order. So for example, I am not a student, or no, I am a student, are very different words. So this one is saying I'm not student, and this one is like responding, no, I am a student, means I am a student, and like they're complete opposites, and the order is extremely important. So we need to maintain this sequence order, or have a way to represent it. We need to keep track of long-term dependencies. So for example, if you are reading a book and there was a character in the first scene, usually the villain comes in like the first scene, does something horrible, and then disappears for the next three chapters. And then when he comes back again, you should be able, or at least your model should be able to remember that this person is the same person from the first chapter. And to share parameters across the sequence. This is extremely important because it reduces a lot of the calculations compared to, as I said, just padding the text engine, sending it through a multi-layer perceptron. Very bad approach, similar to, for example, using multi-layer perceptrons for images. A horrible approach that takes a lot of time, and it does not share the parameters across the different the different parts of the neural network. Recurrent neural network are the answers for this problem. It was built by this dude, but I think we are like running out of time for the project presentations. So I guess for now, let's stop here. On the next lecture, we will speak a little bit about the importance of parameter sharing. And it's very similar, as we said, to images. So for example, if you have a nose on the right or a cat on the top left or a cat in the bottom left or bottom right of the image, you should be able to use the same neural network to detect both. Same thing in here. If you have the data at the end of the sentence or the date in the start of the sentence, you should be able to use the same model to answer both questions. And then we will speak a little bit about the examples or the different types or patterns of neural networks or RNNs in general. And then we will speak a little bit about the calculations, how it's done. It's just basically multiplications and additions. Finish that with backpropagation through time. And once we finish this part, we will speak about the challenges of training exploding gradients or vanishing gradients and how can we solve those. And hopefully, if we have time, we speak a little bit about LSTMs and the applications of RNNs. So thank you guys so much. And I will start by asking those who have presentations to like prepare their implementation, prepare their code, prepare their results, and prepare their data set. And I will go text those who still haven't presented. So for those who already presented, I think that's it for today's lecture. You can drop right now and start working on your or start preparing your final exam and the final presentation.
Thank you. Bye.
Bye-bye. So I'll create the breakout rooms, and we've got so far just 4 people here, but we have 13 in total. Okay. See you soon.
Привет, Вова.
Запись пойдем.
Тут рекординг.